Okay, good morning, students. Uh, I think you have got yesterday's video link. I think some of them have got through it. Okay, so yesterday we were studying about kitchen hood manual calculation, as well as we have gone through some toilet ventilation also, right? Today we have seen kitchen hood ventilation, its CAD drawing, how to draw it, and all we have seen it. And we have just started with toilet ventilation, right? And we have seen different types of ventilation in toilets, ducted type, non-ducted type. And I have said that we are using disc valves mainly in toilets when we are using duct system. Not only that, we'll be using directly an exhaust fan uh, if it is possible. Okay, and we have found out the load calculation of it. We have found out the load calculation in the ventilation system. Like first, you have to calculate the uh, CFM, then we have to convert it into CMH, then we have to find the static pressure of frictional loss, right? Then uh, then we can find out the exhaust fan size. Okay, that was the thing that we were going through. Now I will show you the CAD drawing of a toilet ventilation system. Okay, you can see the CAD drawing of toilet ventilation system. Okay, so I will just share my screen. Okay. I believe you can see this CAD drawing, right? So, I believe you can see this CAD drawing. So these are different toilets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 toilets are there. So I have to find out the ventilation in this 10 toilets. Not only these 10 toilets, some passage is also there in the center. You can see this much area is the passage. And you have 10 toilets. Okay. So I am asking you to just, if for example, if I am asking you to uh, take a ventilation system for these 10 toilets and this passage, okay, what you must do is that first, so how to calculate the CFM? We have the formula, correct? We have the formula. Only we need to do into heat per hour divided by 1.7. So the dimension of the toilet will be given by the architect normally. We haven't given, just we have to measure it. We have to measure like this. This 2 meter into 3 meter. Mostly the height of the building will be 3 meters or 10 feet. Approximately 10 feet. Okay. For any building, normal height is 3 meter. Maybe the normal height is 3 meter. Sometimes it can go beyond 3 meters also. Sometimes some people will be building their house with double height also. Okay. So, but in the normal case, the height of a building is, or a one-story building is 3 meters. Okay. So the first thing is that what you need to know is that the volume of the toilet. So here you can see the toilets are same. One, two, all the 10 toilets having the same dimension. All the 10 toilets is having the same dimension. Okay. Now, so you just find out one uh, CFM of one unit. How much CFM is present in one toilet? We just find it out because all the toilets are same. Okay, just multiply with 10, you will be getting the total CFM in the uh, complete toilet. Okay. So first, what do you have to do? First, you have to know the volume. The volume is equal length into breadth into height. So 2 into 3 height you can take it as 3 meter. Okay, so you will be getting the volume in meter cube. Then you have to give the ACH. So if it's a private toilet, you just give 10 ACH, or if it's a public toilet, you give 15 ACH. And divide by 1.7, you will be getting the CFM. Okay. Now what we have to do is that the CFM of all the toilet will be same. Correct. So you have to, next what you have to do is you have to find the duct size. You have to get the duct size. How to know the duct size? This you can see, this is the main duct. This is the main duct. This is the branch duct. You can see branch ducts. You can see all the branch ducts are same in size. Why? Because the toilet is same. The CFM is also same in all the toilets. Correct. So what is the CFM that we got in this? According to that, we have to size the duct. So we can size the duct by the help of duct sizer software. You just give the CFM here and give its friction loss or velocity. Okay. Mainly we will be giving its friction loss. Give 0.1 as the friction loss. You have to give two values in the duct sizer software. One is the CFM, that is must. Next thing is you can give velocity, or you can give static pressure or frictional loss. Better you give a friction loss. Okay. As 0.1. Give that value as 0.1 in that friction loss column in that duct sizer software. So you will be getting the duct size. So this duct size will be same. This duct size will be same because the CFM will be same. Okay, the CFM will be same. So the duct size, the branch duct size also will be same. Now, coming to this passage also, you have to exhaust the air in the passage also. Not only in toilet, you have to exhaust the air from the passage. So that what you have to do is that you can divide this into 4 equal or 5 equal parts. 1, 2, 3, 4, 5. You can divide in 5 equal parts or 4 equal parts according to your wish. The passage size is given 10.8 meter into 2 meter. This length is 10.8 meter. 2 meter is the width. Okay. So when you are sizing this duct, you can see it's a bigger duct compared to this and this. Okay. The CFM which is passing through this duct will be the CFM in this toilet plus the CFM from this toilet from the CFM or the air from this part. You have to add all these CFM, okay, and you will be getting the total CFM. Okay, the CFM of this toilet plus the CFM of this toilet plus CFM of this area. You have to add all these three, okay, and you'll be getting a total CFM. That CFM you have to put in the duct sizer software and get the duct size. That will be the size of this main duct. What about this duct? You can see it is bigger than this. So how to calculate the duct size of this bigger duct? You have to take the CFM of this one. You have to take the CFM of this one. You have to take the CFM of this one. You have to take the CFM of this one, and you have to take the CFM of this side and this side also. Second one, if you are dividing into 4 equal parts, this area and this part and this part, you add all those CFM, give it in the duct sizer software, and get the duct size. Okay. What about this main duct size? Add this CFM, this CFM, this CFM, this CFM, all these 6 toilet CFM plus these 3 areas. We'll be getting the duct size of this. Okay. What about this duct? You have to get the CFM of this complete area plus this 4 toilets plus this 4 toilet. So that is this duct size. What about this final duct size? The CFM of all the toilets. This CFM complete 5 toilets, this CFM complete toilet plus this complete sections CFM. You have to add all these CFM and give it in the duct sizer software and you will be getting the duct size of this. Okay, better you go from back. Okay, better you go from back. You can size according from here also, but it is very easy. You can size from backwards. So the duct size will be increasing. So I will explain once more. Don't worry. This is the toilet, and you have a passage also. You have toilet and you have passage. Okay. The size of the toilet and the size of the passage is also given. Fine. Now I am going to find out the ventilation. I am choosing an exhaust fan here, and I am choosing that my air has to be exhausted through a duct. This is the disc valve. I have placed the disc valve here. This one. Disc valve. From disc valve, I have taken a flexible duct, then a duct, then I give to a main duct. Some branch ducts. This is the main duct. So how I am going to design? How I am going to design my CFM which is produced in this particular toilet. Discharge in this particular toilet is formula is Q is equal to volume in meter cube into ACH by 1.7. We have already seen that formula yesterday. By that formula, we found the CFM of this toilet. The same way, you can divide this passage into 3 equal parts or 4 equal parts or 5 equal parts according to your wish. Okay, we can divide it according to your wish. And so if I am dividing it into 5, for example, here they have divided only 4. I am dividing it into 5. For example, you take I have divided it into 5. You will be getting initially you will be getting the size of this duct by knowing this CFM, the CFM in the toilet, correct? All the CFM in the room is same, so the duct size, branch duct size is also same. Let's see. But when it comes to this main duct, you can see the size of the main duct will be the addition of this toilet plus this this area, this passage area. Okay, so you have to add this toilet CFM plus this toilet CFM plus this passage area. We have divided into 5 parts. So this is the one part. This is the second part. This is the third part. This is the fourth part, and this is the fifth part. So 1, 2, 3. This 3 CFM is been added, and that total CFM is given to the duct sizer software, and we have found the duct size. That is the size of this duct. That is the size of this duct. Understood? Now coming to the, just assume that there is one more duct here. Okay. Next assume the second duct. To find out this duct, okay, this duct, you have to add this area or this CFM plus this CFM plus this CFM plus this CFM plus this passage area plus this passage area. Then you will be getting this duct size. Okay. Now the third one, how to find this bigger duct size? You have to add this plus this toilet plus this toilet plus this toilet plus this toilet plus this passage area plus this passage area plus this passage area CFM. then you will be getting this duct size. What about this duct size? Add all the 4 toilet CFM plus this 4 toilet CFM plus this 4 divided area, passage area. Add all the CFM, give it in the duct sizer software and get the duct size. Okay, what about the final duct size? This bigger duct. Add all the 5 CFM in this 5 toilet, and the complete passage area CFM. So you will be getting the total CFM and give it in the duct sizer software and get the duct size. Okay, and you have to give a sign of the fan size will be the total step up in this particular room plus if you calculate the static pressure, you can just do the static pressure. Here you have elbow is there. You have to find the static pressure of this elbow. You have reducers. 1, 2, 3 reducers are there. According to that, you find the static pressure also. So 1 second, I am just asking you whether you have any doubt regarding this, or if you are not clear, I will explain once more. So I have opened the chat. So, do you have any doubt? If someone have any doubt in this, you can just give a chat, or I will continue with the next topic. All these things will come in the advanced course only. Just now, I am just dictating this, how to draw and what all, that will be there only for the time being. Then come the advanced course, I will teaching you how to draw it and how to design it and all by yourself. For the time being, I am just explaining how to draw this, that's all. If you have some doubts, I haven't seen any chat. Please repeat the static pressure portion. Normally, static pressure is really find out from X-ray duct fitting software. Okay, there will be in X-ray duct fitting software we have n number of fittings. Fittings means elbows, reducers, okay, different joints. Okay, these are known as fittings. Okay, through these fittings only mainly the friction loss happens. Okay, but to know a basic thing, I have already explained you how to calculate the static pressure, friction loss. Okay, yesterday you have seen, like, if it is a straight duct, you can see straight duct. This is a straight duct, right? If it is a straight duct, 0.004 inches of water column per meter. So you have to see what is the length of this. You have to see what is the length of this. Okay. So here it shows approximately 9.25. You can see 9.25. Okay. So 9.25 meter is the length here. Plus you can see the length here also. Length of the duct. Here also it is approximately how much? 4 meter. Approximately 4 meter. Okay. So 13 meter is the total, approximately 13 meter assumption. Okay. Approximately 13 meter is the total length of the duct. So 13 into 0.004 inches. So you will be getting the static pressure of a straight duct. Plus, how many elbows are there? One elbow. 190-degree elbow. Correct. So plus, for elbow, 90-degree elbow, what is the friction loss? 0.2 inches of water column per elbow. shows per run code. So plus 0.02. So plus 0.2 inches. And how many reducers are there? Reducers are not there, right? Reducers are there. Reducers friction loss will be getting from a software. According to that, you just add all those friction loss, okay, submit, and that is the static pressure. So you'll be getting total CFM plus this much inch or 2 inches of water column. That is its static pressure. You just choose that from a catalog and you just fix it over here. And you can give this much CFM at 2 inches of water column. You can note it here. You can mention it here. That is the way that you have to find out the static pressure. So this is a very simple thing. If you get a toilet, find out the CFM in each room. When you get CFM, go to the duct sizer software and find the duct size. That's all. So always go from back to the front. So this toilet plus this passage area is the total CFM is the you have to calculate the total CFM and go to the duct sizer and get the duct size of this main duct and go backward. So when you are going backward, what happens? The duct size you can see it is increasing. You can see it is increasing. And coming to forward, you can see the duct size is decreasing. Why it is increasing? Because the CFM in this duct compared to this duct is more. The CFM in this duct compared to this duct is more. The CFM in this duct is this CFM plus 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 this CFM. When coming to this duct, the CFM in this room is, or in this duct is, the CFM of this 3 toilet plus this 3 toilet plus this 3 area. Understood? So the duct size also will be increased. So you can see the duct size is very large in this. Why it is very large compared to all other ducts? Because the CFM which is flowing through this duct will be the total CFM. All the toilet will be taken and this passage area also will be taken. According, if the CFM increases, the duct size also will increase. Okay. And coming to this end, what happens? We need only this much CFM, or we have only this much CFM. That's why the duct size is very less. I think you have understood this. I think there is no much explanation. If someone have any doubt, you can ask me. I think it is clear for you. Okay. Why last toilet duct is too long? Why last two duct is too long? Because in this case they have divided only 4 sessions. One session like this, one session like this, one session like this, one session like this. If they have divided into 3, if they have divided into 5 equal sections, the duct size also should be have same. Okay. Because why this is very long? Because this last duct, the CFM they have taken from these 4 directly, 1, 2, 3, 4, and this complete area. So all this comes in this same duct. You can see the same duct. 1, 2, 3, 4. 4 comes in this same duct. When coming to this duct, you see only this 2 will be coming. Here also only 2. Here also 1. So here 4 are there. 1, 2, 3, 4. That's why it comes to the same duct. That's why it is long. Why last toilet duct is too long? The last toilet. I didn't get the real meaning of that. What you have asked. See that the length of the duct size that we are designing. Okay, we can increase or decrease according to our wish. Okay, so here what we have did is that we have individually taken the CFM from individual toilet and we have given to the main duct. Okay, here you can see a disc wall. This disc wall will be directly connected to this main duct. From seeing from top to bottom, you cannot see like this. Okay, this is directly connected to the main duct because this main duct is passing through the toilet only. Okay. Yeah, I think why this long. This is sometimes might be a mistake. Okay, this duct, you can do same as this also, no problem. This might be a mistake. Okay, you can take flexible duct till this much, no problem. I think it is clear. Now, so we have just gone through toilet ventilation as well as we have seen kitchen hood ventilation also. So you can design this according to your way or according to your wish. Okay. If you are not giving this flexible duct also, no problem. We can give directly the duct. Okay, it is not necessary that you need to give this flexible duct. Okay. And we have to choose the disc valve. This is known as disc valve. So according to the CFM that you are calculated, you have to choose the size of the disc valve. So here the size of the disc valve is 150. The diameter is 150. And the CFM I have calculated, I got is 106 CFM. Okay. I got 106 CFM. How I got 106 is that the formula volume in meter cube into ACH divided by 1.7, you will be getting almost 106 CFM. Okay. I don't know what was the CFM ACH I have taken, but I will show you. Like for example, 2 into 3 into length into width into height is 3 meter. So 18 meter cube is my volume into ACH. Into ACH I am, for example, let me give 10. For example, 10. Let me see. Okay. Divided by 1.7. Yeah, I got 1.5.88, which is approximately 1.60. Okay, 1.6 CFM. Okay. With this 1.6 CFM, I have to size the duct. So give 106 as the CFM and give friction loss as 0.1. Okay. You will be getting the duct size. And disc valve, how you got 150 as the disc valve size is that you need to go to the catalog. In catalog, different diameters of the disc valve will be given. 150, 100, 200, 250 like that. Okay, the disc valve dimensions will be given. 100 will be there, 150 will be there, 200 will be there, 250 will be there. That is the normal range of disc valve. So through 100 mm diameter, okay, there is a range of CFM, might be from 50 to 100. So 50 to 100 CFM will be passing through 100 diameter disc valve. Okay, now from 100 to example, okay, from 100 to 200 CFM, the CFM will be 100 to 200 CFM. The disc valve size might be 200 or 150. From 200 to 250 CFM range, the disc valve size might be 200. From 250 to 300 CFM range, the disc valve might be 250. Okay, according to the catalog, we can choose it. Okay. Uh, so do you want to see how to choose the disk wall from the catalog? Yes, you want to see. Okay, one second. Let me take that catalog. The catalog I will be sending to you. Okay, I have already I have just uploaded in this Google Drive. Last I will give you the link and you can just see. Uh, I am going to choose a catalog brand name known as Air Master. Air Master. Okay, let's see. Let me share it. This is the PDF file. Okay. This is the Air Master catalog, and here different things are given. Air terminals are given. This Air Master, this catalog is mainly for air terminals like diffusers, grills, registers, slow diffusers, disc valve. Everything is been given in this catalog. Okay. So in this, how to choose the uh, disc valve is given here in okay 9. Okay, 9 here. Index, the topic chapter 9 about this quality is given. So I'm going to choose 9. So let's see. Different air terminals is being given in this catalog. You can go through the catalog. This is about grills and registers. It's chapter 3, I think it was chapter 9 it seems. Chapter 7. When you are looking this, everything will be given, okay? Everything about its dimensions, how to fix it, what is the velocity, what is the friction loss, everything will be given in it. What is the velocity that will be coming through that. All the specifications and data will be given in the catalog. And in this special catalog, everything is given, okay? Whatever terminal that you are using, you could get the specifications from this catalog. The next chapter is sequence. Yeah, chapter 9, it's about disc valve. Okay, disc valve. We can see standard sizes. Okay, this is known as disc valve. I have already shown you disc valve. Okay, this is disc valve. This is about the position and all those things. It's been given here. But you can just go through it. See, this you can this spindle you can make it inwards and you can make it outwards. So you can make this A minus and A plus. Okay, this area is this one. This one. Okay, sure. This one. Okay, you can bring it inwards and you can bring it outwards also. So you can A minus and A plus. A plus means this will come out. A minus means it will go in. Okay, you just go through that and you can see it. Different sizes is been given. 80, 100, 125, 160, 200. This is the size. This is the size of the disc valve. Okay. Now we can see the total catalog. Maybe it is known as the neck size. Maybe it is known as neck size. There are supply air disc valve as well as exhaust air is also there. So now we are going to deal with exhaust air, right? This is table 9.2b airflow data return air disc valve. Okay, so I will explain how to choose it. The neck size in mm diameter is given. The diameter of the disc valve in mm is given. You can see different values, different standard sizes are there. 80, 100, 125, sorry, 125, 160 and 200. 80, 100, 125, 160 and 200. This is the standard size of a disc valve, because maybe disc valve we are using in toilet, the size of the toilet will be very less. So if the size is very, if it is more, you just give 2 disc valve in a single toilet. You can give 2 disc valve if the size is large, or if the CFM is very large. Okay, you can increase the number of disc valve also. It is not necessary that you should give only 1 disc valve. According to the size of the toilet, according to the CFM value, you can increase the disc valve also. You can see CFM, 10 CFM, 20 CFM, 40 CFM, 80 CFM, 60 CFM, 80 CFM, 100 CFM, 150 CFM and 200 CFM. This is the CFM range. So in this, what was our CFM? 106, right? 106. So this will come in this range. So there is no 80 as well as there is no 80 mm size. There is no 80 mm. You can choose 100. You can choose the diameter 100. But when you are choosing the diameter 100, what happens is that you can see the noise criteria NC. If you are choosing noise criteria, the NC is 37. Okay, and A is 0. We can see A plus 10, A 0, A minus 10, right? That is that width. I have already shown you that width is there now. This one. This one. A minus means this spindle is coming inside. A plus means the spindle is coming outside. You can see here. A0 means this will be on this line itself. This will be parallel or plane. If A is plus or if A is minus, okay, what happens is that it is also given. See, if A is plus, what happens? The noise will be less. The noise criteria in decibel is 37. If A is 0, what will be the noise criteria? It is 45. If A is minus 10, that will be greater than 45. So mainly we have to make sure that NC, which noise criteria means sound, the decibel should come, the maximum should be 35. So it goes beyond 37. It goes beyond 35. You got the value 37, 45, greater than 45. So when you are choosing this air terminals, you have to see what is the noise criteria also. You have to see this specification also. So it should come below 35. If it goes above 35, the sound will be more. If it goes above 45 also, see. So what you have to do is that Go to the next size, 125. Go to the next size, 125. So for 100 CFM or for 106 CFM, if you are choosing 125 mm diameter disc valve, just see what will be the noise criteria. It's only 25. Okay. If A is 0, it comes to 35. You can choose this. If it is A is plus 10, it goes greater than 45. So you have to make sure that the A should be in 0 or A should be in plus 10. So that the noise criteria, we can adjust the noise criteria. Or if it is not possible, what you have to do? Go to the next size. Go to the next size. Take 160. Diameter, you take 160. If you are taking 125, it will be fine. Okay. Okay. Or you can go to the next option, 160. When you are choosing the next option, 160 for 100 CFM, the noise criteria will be less than 20. At A is equal to 0, the noise criteria is 25. At A is equal to minus 10, the noise criteria is 35. So you can choose 160 also. That will be better. If you are choosing 125 also, no problem. You can choose that also. Okay. So this is the way that you chooses the air terminals. Here we are choosing the disc valve. So without catalog also, you can go to the software known as beta software and you can get the size. I don't know whether you will be getting the disc valve. Rest everything you will be getting it from the beta software. Disc valve, you go like this and you choose it. Yeah, so NC should be maximum 35. Okay, so when you are designing also, when you are going with the software also, they will be asking what is the maximum NC. So there you give 35. Okay, so when you give 35, according to that, the software will be processing it, and you will be getting, that software will be giving you the size. In the software, they will be asking what we have to give, and they will be asking what should be the maximum noise criteria that you are trying to give. So we have to give 35 as the maximum. Understood? So this is the way that we will be choosing it. Okay. Mainly it is for all the terminals. Okay. It is asking, is it for all terminals? Yeah, it is for all terminals, not only this one, because noise is already, it's a part, right? So there should not be much noise. If you are giving 35 or 40 also, no problem. It is only just a ventilation, it is toilet, right? So yeah, it is not an issue. So better try to give within the limit of 35. If it goes, if it is 37 or 40 also, it's not a big deal when coming to the ventilation system. Air conditioning and all, you have to give. Air conditioning also, you will be giving the air terminals, right? Like diffusers, grills, like that. In that cases, you give maximum 35 as the noise criteria, or 35 decibel as the noise criteria. Okay. So this is the way that you will be choosing it. Whatever air terminals you need, you can choose it from this software or from this catalog. So everything is given here. This is the round ceiling diffuser that you just go through and you can just get it. Different types of air terminals are there. Okay, so you can choose whatever you want. Okay, so this many different types are there. Okay. Now we have gone through the toilet ventilation as well as kitchen hood ventilation. Now write today's date with this also, and write car parking ventilation. We can just deal with car parking ventilation also. Okay, car parking ventilation. So why we need to give car parking ventilation? What is the purpose of car parking ventilation? Someone can chat. What is the purpose of car parking? Why we need car parking ventilation? Is it necessary that we need to give car parking ventilation? Yes. Why we need car parking ventilation? Okay, parking might be underground. Yeah, the emission from the car will be there, right? So mostly this car parking will be in the basement. Not only now multi-story car parking, buildings are also there. Okay, multi-level car parks are also there. But mainly we have seen the car park, yeah, extraction of carbon monoxide. Mainly this emission will be produced from this vehicles. So a good ventilation system should be given to this car park. Right? Yeah, that's fine. Yeah. Now, write car parking ventilation and just write about it. A small description. Car parking ventilation. Ventilation is provided in the car parking. Ventilation is provided in the car parking. Ventilation is provided in the car parking. To exhaust the smoke. To exhaust the smoke. To exhaust the smoke produced from vehicles. Produced from vehicles. Produced from vehicles. And other air with impurities. And other air with impurities. And other air with impurities. So here also the same way there are ducted ventilation as well as ductless ventilation. You can give an exhaust fan directly to the outside. Even if you can give supplier also, no problem. You can give the combination also. Okay. So here also ducted ventilation is there, ductless ventilation is there. In ducted ventilation, you will be taking the air through the duct and you will be exhausting it. Okay. Ductless means directly you will be placing the exhaust fan. Okay. So here also to find out the ventilation, we are using the same formula. Don't just confused with this air conditioning and ventilation. Here we are just considering only ventilation. Okay, so we are using the same formula that we have studied for toilet ventilation to find out the CFM. What was the formula? What was the formula that we have used in toilet ventilation to find out the CFM? Q is equal to volume in meter cube into ACH by 1.7. If the dimension is given in feet, volume in feet cube into ACH divided by 60. Okay, when you are giving the value in that equation, you will be getting the answer in CFM only. You will be getting the answer in CFM, cubic feet per minute. Okay, not to get the correct conversion only, we have divided by 1.7 and we have divided by 60. The answer for the unit that will be getting the amount of air to discharge, the unit will be in CFM. Okay, whether if it is whether if the dimension in the toilet we have seen the dimension in meter only, 2 into 3 meter only. Okay, sometimes if it was given in feet, okay, you can just convert it to meter and you can find it out. But still, if it is feet, you can just directly find out volume in feet cube into air change per hour divided by 60 if it is in feet. If it is in meter, polymin meter cube into ACH divided by 1.7. You will be getting this CFM. Okay, I think that is clear. Now we can write the heading types of ventilation in car parking. First one, ducted ventilation. First one, ducted ventilation, and write that formula. Q is equal to V in meter cube into ACH by 1.7 or V in meter cube into ACH by 60. Give that formula. ACH means air change per hour. Okay. In ductless ventilation, we will be giving an exhaust fan. Okay. In ductless ventilation, we will be giving normally axial fan or impulse fan or centrifugal fan or industrial fan. Okay. So second point is ductless ventilation. What type of fan we are usually giving? Ductless ventilation. Ductless ventilation. Ductless ventilation. Axial fan or impulse fan. Just write the name of that fan. That's it. Axial fan or impulse fan. That are the normal exhaust fan that we will be using. Axial fans or impulse fans. Second option is centrifugal fan or industrial fan. Okay, centrifugal fan or industrial fan. And not only we will be providing the exhaust, sometimes we can provide the fresh air also. Sometimes they may be providing only exhaust. Okay, when exhaust is being given out, what happens normally a negative pressure is created inside, right? So the outside air will be automatically coming inside. Do you have any idea from where this outside air will be coming inside? Mainly it will be in the basement. So do you have any idea from where this negative pressure is created? So in car parking, mainly in car parking, I am asking, from where this air will be coming inside? No, if there is no makeup fan, I'm asking if there is no makeup fan, if we are providing only exhaust fan, a negative pressure is created. So from where and all this air can become inside to our home? Through wall openings? Yeah, I am asking basically about the car park. Is there any opening in car parks? Usually from where this outsider can come normally. Just think about it. Yeah, Kirti is saying, yeah, correct. Yeah, yeah. Entry and exit openings. Okay, through entry and exit openings, it's already an opening, right? It's a big opening. So when an exhaust is produced, automatically the air from the entry or exit ramps, okay, uh, will be coming directly into the room, or the room in the sense will be coming directly into the car parking area. Not only that, if you want to give supply air fans also, you can give. You can give the combination of exhaust as well as the supply air. That is not an issue. If you are giving only exhaust also, the air from the outside also can come in, mainly through the exit and entry place or entry ramps. Okay. So just write the heading of supply fans also, supply fans. So fresh air is usually provided. You can write it. Fresh air is usually provided via the entrance, via VIA, via the entrance, via the entrance slash exit slash exit slash exit ramps, RIMPS, ramps. And lowered inlets, and lowered inlets. But sometimes in multi-level car parks are there. So in multi-level car parks, you have to give supplier to each level. Okay. So for multi-level car parks, write it down. For multi-level car parks, pressure is provided at each level of park, each levels, LEVELs, each levels of park. Pressure is provided at each levels of park. Okay, and can be through the supply air fans also. As I have already said that we are using the same formula of toilet ventilation in car parking ventilation also, right? We have to know what is the ACH. This ACH will be just, we are not giving simply a value like 10 or 15 like that. Okay, the ACH value is being you have to follow some guideline. From that guideline only we will be choosing. This much should be given. Okay, so here I will show you. We have a guideline. Okay, from that guideline only we will be choosing. Okay, here we are choosing from NBC, National Building Code. Okay, from National Building Code I will show you. NBC 200 to 2016 moving 1.4 fire and safety. Part 2 mechanical ventilation. Before that, see, this is the National Building Code. Okay, National Building Code, NBC, India. Okay, as per National Building Code 2005. As per National Building Code 2005, for normal operation it was 9 to 12 air change per hour. For fire operation, if there is some emergency or something like that, you can just give 30 AC pH, air change per hour. It was the National Building Code of the regulation 2005. Now it has been cancelled. As per the National Building Code of 2016, this we are using. It's been reduced to, for normal operation, it has been reduced to 6 ACPH. And for fire operation, it is 12 ACPH, or air change per ACH value. Okay, so This is the thing that we have to choose. You have to choose 6 ACH. Okay, or 6 ACH air change per hour. So volume in meter cube into 6 ACH divided by 1.7. In the case of normal operation, when it comes in fire operation, we can give 12 ACH. So in that case, we can give more number of fans to achieve 12 ACH. Eventually, you'll be running only 1 or 2 fans. In fire operation, what happens is that in emergency situations, you have to increase the number of exhaust. Okay. So note this down. Okay, National Building Code ACH standards. ACH standards for normal operation is 6 ACH. And for fire operation, it is 12 ACH or ACPH, whatever it may be. So here currently we are using the NBC of 2016 regulation only. Okay, maybe you have finished. Now just we can discuss something more. Ventilation rate requirement for mechanically ventilated underground car parks. For enclosed underground, this is what the NBC says. Okay, just we can just read it what they are written there. For enclosed underground car parks without provision of natural ventilation, if it is an enclosed underground car parks, a minimum ventilation rate of 6 ACH, 6 air change per hour, shall be provided to keep contaminants within acceptable hygiene limits. In large basements, each compartment shall be independently ventilated at a minimum rate of 6 ACPH. So, minimum, they are saying that minimum you have to give 6 ACH or 6 air change per hour. Okay, so the minimum ventilation rate is 6 ACH. But then when it comes to a larger, car parking area, you have to divide it into compartments. So when you are dividing it into compartments, it will be showing this much should be this much meter square should be one area. Okay, this much square feet should be the other compartment. It will be given. Okay. So if it is a very large basement area, you have to divide it into compartments, and each compartments you have to ventilate. And in each compartment you have to give minimum 6. So minimum, okay, minimum 6 air change per hour. Okay. So when it comes to car parking, you can give 6 ACH. Okay. And if it is the area of the basement is large, you have to just divide it into compartments, and for each compartment you have to give 6 ACH as the ventilation value, air change per hour value. Now the system requirements, what they have written. The underground car park ventilation system can be classified as supply only. You can give supply only also. Exhaust only. So you can give supply fans, you can give exhaust fans, or a combination of the two. Okay, both you can. You can give supply fans, you can give exhaust fans, as well as you can give both the combination of supply as well as you can give exhaust. Okay. A system of ducts or impulse fans or jet fans, we'll be calling only as jet fans, may also be used for proper distribution of air in the car park. So for proper distribution of air, we could give ducts. So when you are giving ducts through the air terminals, we can easily distribute in an equal ratio. Okay. So we could use that also, impulse fans also, or we could use duct system also. Okay. And that are the main things that you need to know from here. And when it comes to the compartment area, basement car parks, the compartment area in meters square should be 3,000. So one compartment should be, uh, uh, you know, around 3,000 meters square. So if it is more than 3,000, there should be another compartment. So from each compartment, you have to give 6 ACH. You have to ventilate it. It needs ventilation. Okay. So mainly we are dealing with basement and car parking. That's why I have taken this. So each compartmentation area should be in the range of 3,000. Okay. Now, smoke exhaust system were provided for above areas, and occupant shall be having minimum 12 air change per hour. When there is smoke or some, because this car parks some smoke, of course. Okay. In a fire operation, we have to give a minimum of 12 ACH. Okay. And the pressurization system where these all will be coming in a stairwell pressurization. Okay. Mainly stairwell pressurization will comes in firefighting, but it is just a part of HVAC also. That's why I am just just briefing this also. Okay. All this comes in stairwell pressurization, which is comes in firefighting, but it is also a part of HVAC also. That's why I'm saying this. A pressurization system where provided shall have a minimum pressure of differential of 20 to 30 pascal in relationship to other areas. So when you are giving pressurization, when you are giving supply air, you should have a pressure of 20 to 25 to 30 pascal. Okay, leave that. Now, the other important thing is that the smoke exhaust fans. See, when you are dealing with the basement car park, you should not give a normal exhaust fans, which will burn easily if a fire occurs or an accident occurs. So when you are selecting an exhaust fan, you have to look into this criteria also. What is that criteria? The smoke exhaust fans in the mechanical ventilation system shall be higher rated, which means that it should be able to withstand 250 degrees Celsius for at least 120 minutes. For at least 120 minutes, 2 hours, the smoke exhaust fan should be higher rated. It should be able to withstand about 250 degrees Celsius for 120 minutes. Okay. So I think if you want to write, you can write. Okay. Just just if you want to write the highlighted thing, you can just highlight and write. So it will be useful for you also. The basement car parking, the compartment area is 3,000 meters square. And smoke exhaust system were provided for above areas, and equipment shall have minimum of 12 air change per hour. Smoke exhaust mechanism. Okay. Now, when it comes to smoke exhaust fan, the mechanical ventilation system shall be fire rated. Fire rated also should be there. So you should be concerned about that also. When you're choosing an exhaust fan, it should be fire rated, and which means that it should be able to withstand 250 degrees Celsius for 120 minutes. Just write only the highlighted value, highlighted thing. That's fine. That is enough. Once you finish, just give a thumbs up. Okay. Fine. Now, there is one more topic known as fan loss. FAN, LAWS. Just you have to just to understand that. That's enough. We are not using in many areas also. But as there is a topic that I'm just saying it. Okay. This fan loss means just comparing two fans. Okay. We are just comparing two fans, or not to find one property of a fan. We are just comparing with another fan of a same property, or an ideal fan. We are just comparing. It's RPM, it's static pressure. Okay. It's it's BHP. Okay. Its density, everything. Just to compare one fan with another fan. We are just comparing one fan with another fan, but this both the fans should have equal properties. Okay. So uh, just write a heading. That's all. Just understand that's enough. Fan loss, LAWS, and not LOSS. It is LAWS. Okay. Fan loss. And write the fan loss are used to find out. Fan loss are used to find out. Fan loss are used to find out the properties. Fan laws are used to find out the properties of a fan, properties of a fan, of a fan, with relate to an ideal fan, with relate to an ideal fan. So just we are comparing the properties with respect to another one ideal fan. One ideal fan. Mainly it is used for fan balancing. Okay, mainly used for fan balancing. Just to compare, and we can write used for fan balancing. And there is there are formulas, and you can just compare it and you can find it out. I'll share the screen. Just don't get confused with this. Simple only. These are the laws governing the performance of a fan and are used to convert the performance of a fan from one set of variables like speed, size, air density to another. Okay, this convert the performance. Okay, because if the performance of a fan is known for a given size, if one performance of a fan is known to us, like its size or RPM or air density, its performance of another size RPM or air density can be computed. This means that we are just comparing it with one ideal fan with the another. So in the case if it is air volume, the air volume of the second fan with respect to first fan, you could just equate like this. Q2 is equal to Q1 into N2 by N1 into T2 by D1, the all. The same way P2. Okay, you can just equate in this formula and you could find the P2 value. W2 also you could find. Just comparing with this. Okay, where N is RPM, D is the fan size, P is the air density. For application of fan laws to size, the fans must be, this is the criteria in which we need to size it. Okay. Both the fans should be geometrically similar. Then only we'll be able to just compare this. The both fans should be geometrically similar. Okay. Fans are geometrically similar if, when can we call a fan is geometrically similar? The number of blades and vanes are same. The angular dimensions are same. All linear dimensions change in proportion to the wheel diameter. Okay. When all these criteria satisfies, we could say that it is geometrically similar. Only geometrically similar two fans can be able for fan balancing, because we are comparing one with the another one. Just comparison. That's it. Okay. So the efficiency of the fan does not change with RPM or density. However, there is a minor increase in the efficiency of larger sizes due to what is known as size effect. So the efficiency of the fan really won't change. Okay, but the efficiency increases in larger sizes due to the fans and due to the non-effect known as size effect. So just keep it in mind that this is fan laws. Fan laws are used for fan balancing. It is used for comparing the property of a one fan with another fan. And if you need to compare this both, you have to keep it in mind that both the fans should be geometrically similar. So geometrically similar in the sense the number of blades and vanes should be same, angular dimension should be same, the linear dimensions change in proportion to the wheel diameter. All these criteria satisfies, then we can call it as geometrically similar fans. If they are geometrically similar, you could compare it and you could find the properties of one fan with respect to another fan. Okay. It is not an important topic, but still, you just you should have an idea what is fan laws, why we use. Okay, and you can write this. Okay, you can write this. We can wind up the topic. This is just a comparison. Okay, comparing one property with another property. You can write according to your way. If it's a point wise, also no problem. Once you finish, just give me a chat. Sorry, not a chat. Just give me a smile. Once you finish, you just give me a thumbs up, okay? I think you have finished this. So, yes, I forgot to show you the car parking ventilation. So, I will show you the CAD drawing of this car parking ventilation. So, this is the car parking ventilation. Don't worry about this car and all those things. This will be given by the architect. Okay, this architectural drawing will be given by the architect. Uh, what we have to do is that we have to design the duct size. Okay, we have to decide the duct size. Okay, if you want to give grill, you can give grill. If you want to give diffuser, you can give diffuser according to your wish. Okay, so if you are getting, for example, if you are getting a car park like this, do you have any idea? We have studied about kitchen hood as well as we have now gone through the toilet ventilation. and we have studied about the car parking ventilation also. So if I am giving you this uh, car park, okay, you have two sides. One car park is like this, one compartment is like this, another compartment is like this. Would you able to design an exhaust as well as supply according to your design? Would you be are you in a position? Will you be able to design, or will you be able to size the duct as well as the uh, air terminal? Just choose from the catalog. That might be one. Would you be able to? Are in a position that you can find out the duct size? Will you be able to design it? If I am giving you this, if I am giving you this car park, okay, if I am giving you this car park, will you be able to design? I am asking that I need a ventilation system for this. There are two compartments here. Will you be able to? How you will start this project, or what you will try to do first? Any idea? We can discuss step by step. Everyone can just give a chat. If I am giving this first, what you will be doing? First, what you will be trying to do? Yeah. One, will you have answer? What about the rest people? First, what you will be doing? First, what you will be taking? Or what will be the first step that you will be considering when I am giving this car park? I am giving this car park to you, and I am asking I need a ventilation. So, what you are going to do? We have already studied, okay? We have already studied it step by step and all those things. This time asking. You guys are already there or no? Or only you are, you have paused your videos and you are not there right now? That's the thing I will ask you to just on your video, okay? So, classify air quality. Okay, fine. We know, na, right? Obviously, we know that what type of air it is inside the car park, right? So mainly we won't circulate it, or we'll be just exhausting it out. Right. After the classification of air quality, what we will be doing? What about Manivannan and take up Kirti? Any idea? What should be the first step? Yeah. So Vinu is saying that first we have to find the CF required. Shepherd is saying that first we have to classify the air quality, then calculate the CFO. Kirti is saying that decide how many ducts required. So, before deciding how many ducts that we need to decide, yeah, decide whether it is ducted or non-ducted. Okay, Vinu is saying that again we have to decide ducted or non-ducted. So first thing is that we have to study the project. Okay, we need to see what is the area. We need to see what is the area, and according to the area, we will be deciding What is this? Okay, according to the area and the site conditions, we'll be deciding whether we need to give a ducted or a non-ducted system. That's right. For example, if you are giving a ducted system, we are choosing to give a ducted system. The first thing that we need to do is we have to find the CFM of it. So in order to find the CFM, what you need, what are the inputs that you need to find out the CFM? I'm teaching you in such a way that you should be able to do a project. Okay? Even though I'm not trying to give you a project, but still you have to practice it. So what you have to, what are the inputs that you need uh, to know the CFM? Yeah. Yeah, we say that we need the area of this space. Yeah, that's correct. We have to know the area. To know the area, we have to measure it. Okay. Given like 9,000. That means what about this? Well, it is given us 15,000, which means 15 meter. 15 meter length and 10 meter width. So we got the area. Okay. So the formula is volume in meter cube into ACH by 1.7. So you can take the height, normal height as 3 meter. Okay. So you got the volume. Now you have to implement the ACH value. You can give 6 ACH or 8 ACH, whatever it might be. Then divide by 1.7, you got the CFO. When you get the CFO, as as Vinu said, we have to decide whether it is ducted or non-ducted. We have already decided it is ducted. Then, as Kirti said, that how many ducts we have to place it. Decide how many ducts we need. I think she meant that how many ducts or how many times we have to divide it. So you can see here, exhaust air. So they have divided into 2 compartments. So this compartment they have given exhaust, as well as this they have given a fresh air duct as well as return air duct. Okay, fresh air and return air duct. So here the length is 15 meter and width is 10 meter, and you have got the total CFM of this complete car park. Now it is equally divided into 2. So just divide the CFM into 2. So the half of this total CFM will be coming to this compartment. Half of the total CFM will be coming to this compartment. Okay. Yeah, we have to divide it. We have to divide it equally, as we have divided the passage of the toilet ventilation into 5 or 4. The same way we have to divide it. Then only we can equally split and we can give it. Okay. For example, what we have found out is that the total CFM we have found out. So if it is divided into 2 equal parts, give the half to this compartment and give the half to this half CFM to this compartment. For example, if you got 5,000 CFM for this complete compartment and 5,000 CFM for this complete compartment, total 10,000 CFM, we are going to size the duct. Okay, this 5,000 CFM I am going to divide it into, that I am deciding whether I need to divide into 2 equal or 3 equal or 5 equal or 4 equal, or that is my design. I am going to decide, or I am going to decide it. Okay, so when deciding, I should be in my mind, I should design in such a way that I should equally distribute it, or the exhaust air should be equally exhausted from each segments or each zones or each portions. So according to that only I will be dividing it. So I can divide into 4 equal parts or 5 equal parts or 6 equal parts according to my wish. So here what I have did is that I have divided into 4 equal parts. 1, 2, 3 and 4. This length of the duct you can change according to your need, okay? And you can divide it into 4 equal parts, taking the dimension of this length, and you can divide it into 4. Okay. I will explain this. Okay. What will be the friction loss while duct sizing? You can give 0.1. There will be a topic for duct designing. I will teach you that. Okay. I will explain this once, and then we can just start. So I have divided into 4 equal parts. Okay. So I got 5,000 total here. Okay. So I have 5,000 or, for example, if it is 6,000, so I am dividing into 4 equal. Okay. Or 8,000, for example, take 8,000. If I got 8,000 CFM in this chamber, so I have divided into 2. Divided into 4. So 2,000 CFM to this side, 2,000 CFM to this side, 2,000 CFM to this side, and 2,000 CFM to this side. I have divided into equal 4 parts, that 8,000 CFM. Okay. So I am going to size the duct. I am going to size the duct for 2,000 CFM. So in this case, I got in actual case when I am sizing it, I will get only 1,324 CFM. Okay, let's go with that. 1,224 CFM is the value that I got for this compartment. I have divided into 4 equal parts. So 1,324 divided by 4, I will be getting 331 CFM. Okay, let's see, 1,324 divided by 4, I got 331 CFM. For this 331 CFM, I found the return air duct size by the help of duct sizer software. Now, what will be the CFM in this duct? The CFM in this duct will be the air which is coming through this as well as this CFM also. Correct. So 331 plus 331, 662 CFM. What about the size of this duct? 662 plus again 331. What is the size of this duct? 993 plus 331. Okay, but the air that is flowing through this grill will be 331 each. Here it will be 331. Here it will be 331. Here it will be 331. Here also it will be 331. When coming to the main duct, the air will be passing through this will be the total air. Here only 993 because 331 CFM is already exhausted. First only 993. Here again 331 is being lost. Again here only 662. Again 331 is lost. Rest only 331 is left. I think you can understand what I am saying, right? When it comes to the fresh air duct, take just 80% of the return air, and according to that you size it and divide it into equal portion. And this symbol shows the fresh air. It is coming from the top and it is being supplied. This symbol shows the exhaust. It has been exhausted to outside. So this is the grill. This is the grill. Okay, that has to be sized by the help of beta software for 331 CFM. For 331 CFM, what will be the grill size? That you can size from the beta software or you can choose it from the catalog also. Okay. Now, is there any doubt regarding this? Or if you haven't understood this, I will explain once more. The same way, you can just copy it and you can place it here also because both the compartments area are same. When is asking ACH is 6. Yeah, you can give the ACH value minimum 6. Give ACH 6 and find the volume and find the CFM. And according to the CFM, you just divide the compartment into equal parts, 3 or 4 or 5. Then should be considered 12 ACH. 12 ACH will be considering in the fire mode. When there is some smoke or some accidents happens like that, you have to consider that. So in that cases, normally we'll be giving many supply fans or many return fans. In that case, all the fans will be working. In other case, it will be only 2 or 3 will be working in between like. Okay. So in 12 ACH will be all the fans will be working. So normally you give 6 ACH. When there is smoke or something like that, there is a chance of producing that. Just give 12 ACH or 10 ACH like that. Kirti is asking like, to the duct size increase, do we have to add CFM, right? Yeah. When the CFM increases, the duct size also increases. So here, we got 1324 CFM total to be exhausted. I have divided into 4. So 1324 divided by 4, it is 331. So 331 will be passing through the side, 331 will be passing through the side, 331 will be passing through the side, or entering to this duct, or 331 will be entering to this duct also. When come to the size of the main duct, the air in this duct will be the addition of all these 331, 331 plus 331 plus 331 plus 331. When it comes to this duct, the CFM will be 331 plus 331 plus 331. And coming to this duct, the CFM will be 331 plus 331. Rest, this duct only 331 is left. I think my answer is yeah. So if you are dividing it into 5 different, this 331 will be again will be less. So you could have 5 drills here. Okay? You could have 5 drills here. And the 331 also will be coming less. It might be 300 or 250, like 280, like that. Yeah, if all the fans work together, thus the duct size will be sufficient for the floor. Yeah, that will be sufficient, but we'll be designing with minimum 6 and will be given 6 to 8 or 8 to 10, like that. Okay, ACH might be minimum only 6, they are same. So in the normal car park out, we'll be giving 6, but sometimes we might design with even 10 or something like that. 10 or 10. Better you just go with 12. Okay? Better go with 12. I won't need very much differences in that. Give ACH value 12 and you can decide. That's not an issue. It should be minimum 6. That's what they have been asking. So when you are considering the fire mode, we can give 12 also. So here you have to design the duct size as well as you have to design the size of the grill also. You have to give exhaust as well as you have to give supply. And you can give supply 80% of the exhaust here. So if it is not if all these areas are outside area, you can give direct exhaust fan also. That is also not an issue. This ventilation is also very important, okay, when it comes to HVAC. Designing of ventilation is also important. and if I get a time, I will uh, just teach you how to calculate this. Sometimes if a fire happens, okay, how to exhaust, how to do the ventilation calculation. Okay. So when a fire happens, we won't take this complete area because the fire won't happen in this complete area. The fire, sometimes the fire might be in this small area. You understood? The fire means, don't think that this full building will be in fire. Some days as fire will be only in this side. Okay, so a smoke will be generated. So to exhaust that, we'll be having a calculation. How much area that we need to choose, we'll be having a calculation. If I get time, I will just include that also tomorrow. Okay. And what is the method or what is the formula that we will be using? How do we check that we have the correct supply on the air terminals? Like we'll be having instruments, not only that, we'll be designing. Okay, we are designing according to that only. We are designing the duct size. We are giving duct size, right? Why we are giving a proper duct size? Why this duct size changed? Okay, here it was 400 to 300. Now it becomes 350 to 250. Now it becomes 250 to 200. Why this duct size change? This duct size change so that the air should pass through this or air should come to this. That's why we are sizing it. For example, plumbing also, the water pipelines is sized so that the proper amount of water should reach in our fixture or in our toilet. So we are sizing in such a way that the air has to be distributed equally. Okay, that's why the sizing is important. When we size it, we are making sure that the air is being equally distributed in each area. Not only that, when we are selecting this air terminal also, we'll be sizing it. We are not giving just a air terminal. We are sizing according to the flow. I think there is no much doubt, it seems. So there is no doubt, we just give a thumbs up. We can pause it. I think today we have studied about car parking ventilation, toilet ventilation. We have seen the CAD drawings. We have gone through the CAD drawings. We have just seen how to design it, how to split the areas, how to calculate the CFM. Okay. And coming days we can see how to size the duct through the duct sizer software. Okay. Kirti is saying that yesterday's class I was not able to open the link and see the video. Could you please reshare it? Yes, I will reshare. What about other guys? Was there any problem in opening yesterday's video link? Or have you just opened it? Api was able to open, right? What about Shepherd and other? Did you open or just I need one more piece? Kirti is saying that she was not able to open the link and see the video. Anyway, I will reshare it. Yeah, Excel sheets and everything I will give you in the end. Or let me see, because I have just included in one just drive. Like there are softwares and all these things. Okay, and I will give you it. I'll give you the link of the drive. So what about the yesterday's video? Is there any problem in watching it? Please just confirm it. Now, in the sense means, is it you able to see it? able to watch. Yeah. So Kirti, I will just make sure that I send you that also. Okay. Anyways, for today, this might be enough. Okay. So tomorrow we will be dealing with the ducts, different ducts, shapes, materials, all those things. We can deal with it. Okay. And insulations and all those things. So tomorrow also it's an important day. Tomorrow in the sense, tomorrow Saturday, na? Monday. Okay. So just go through what we have studied. Okay. If possible, go to the video and just see once more. Okay. If there is any doubt. So thank you so much. So take care. Bye.